My name is S. Reshma. I am from ECEB section. Today's my CAA2 assignment topic is design of a 4-bit comparator using conditional statements. 4-bit comparator. A comparator means which compares two inputs. A 4-bit comparator is a digital circuit that compares two 4-bit numbers and determines their relationship, whether one is greater than, less than, or equal to the other. This presentation covers the design of such comparators using conditional statements of a fundamental concept in hardware description and digital design for decision making process. Comparator. Normally, a comparator compares the two inputs if they are greater than, less than, or equals to. In electronics, a comparator is a device that compares two voltages or currents and outputs a digital signal indicating which is larger. This is a comparator. A truth table of a comparator. If A, B is inputs, then A greater than B or and A equals to B is the outputs. When we give A, B as inputs as seen in the slide 00110101, then A, B are equal 00. Then output enables in 1 A equals to B. If A is 0, B is 1, then B is greater than A. So there is no output. When A is 1, B equals to 0, then A is greater than B. Here is output is 1, where A equals to 0 is 0. A equals to B is 0. If A is 1, B is 1, that condition is called A equals to B. This is 4-bit comparator block diagram. If there is two inputs A, B and A 4 bits are A3, A2, A1, A0. If B is 3 bits, if B has 4 bits, they are B3, B2, B1, B0. There is VCC and ground is same, whereas A is greater than B, A equals to B, A is less than B are the outputs. This is an integrated circuit. There is a logic diagram of a magnitude comparator. We can see after truth table of magnitude comparator. Conditional statement logic for comparison. In a 4-bit comparators, conditional statements evaluate each bit pair sequentially to establish the relative magnitudes. They implement logical decisions like if-else constructs, allowing the circuit to determine equality greater than or less than relationships effectively. This logic underpins precise stepwise comparison and ensures correct output signaling for all input combinations. In each input, A and B are inputs. A have 4 bits. This is a 4-bit comparator, so A have 4 bits that equals to A3, A2, A1, A0. If B is another input and it is also have 4 bits B3, B2, B1, B0, where A equals to B, then A3 equals to B3, A2 equals to B2, A1 equals to B1, A0 equals to B1. A equals to B is expressed in this equation form. This is a logical expression for A equals to B. A3 exclusive NOR B3 into A2 exclusive NOR B2 into A1 exclusive NOR B1 into A0 exclusive NOR B0. This is obtained from the 4-bit comparator truth table. We will see the truth table and also analyze how it obtained. There is a logical diagram for logical expression A equals to B3, A equals to B. When A3 and B3 are inputs exclusive NOR, they are connected with the exclusive NOR operation. We use exclusive NOR operation, and A3 exclusive NOR B3 output will comes to the AND gate. Because of A3 exclusive NOR into A2 exclusive NOR B2, the two expressions between there have a AND gate as an operation. So we have to give the outputs for AND gate, and AND gate will evaluate outputs A3 B3 as inputs, and XNOR operation will execute, and AND gate will give the outputs A2 B2, A1 B1 and A0 B0. There is a greater than B. For this condition, there we simplify the logical expression. Is similarly A equals to B, A has 4 bits and B has 4 bits. A equals to A3, comma A2, A1, A0, and B equals to B3, B2, B1, B0. When A greater than B, then A3 greater than B3. If A3 equals to B3 and A2 greater than B2, or if A3 equals to B3 and A2 equals to B2 and A1 is greater than B1, or if A3 equals to B3 and A2 equals to B2 and A1 equals to B1 and A0 is greater than B0. When these conditions are true, then A is greater than B. There is a logical expression for A is greater than B. A3 equals to B3 bar. When A3 is greater than B, then A is 1, then A3 is 1, B3 is 0. 1 is the real binary number, and 0 is a complement for it. So 0 represents as bar. A3 B3 bar. A3 exclusive NOR B3. In previous slide, we, we assume as A3 equals to B3 equals to A3 exclusive NOR B3. So we have to put A3 equals to B3 replace with A3 exclusive NOR B3 into A2 B2 bar, whereas A2 is 1 and B2 is 0. A3 exclusive NOR B3, A2 is A2 exclusive NOR B2, A1 B1 bar plus A3 exclusive NOR B3, A2 exclusive NOR B2, A1 exclusive NOR B1, whereas A0 B0 bar. When A is greater than B, then A bits A3, A2, A1, A0, they all become as 1, where B bits or become 0. So they have B bar. Next, this is A greater than B logical diagram. There is AND operation is performing in logical expression. So we have to connect. We have give inputs for AND operation A3 B3 bar. And another conditional statement is A is less than B. When A is less than B, A equals to 0, B equals to 1. A is less than B. Similarly, A bits are A3, A2, A1, A0, and B bits are B3, B2, B1, B0. A is less than B. Then A3 is less than B. Or if A3 equals to B3 and A2 equals to B2 and A1 is less than B. If A3 equals to B3 and A2 less than B2. If A3 equals to B3 and A2 equals to B2 and also A1 equals to B1 and A0 less than B0. When A0 is less than B0, then A equals to 0, B equals to 1. So A3 bar into B3 plus A3 exclusive not B3, A2 bar B2 plus A3 exclusive not B3 into A2 exclusive not B2, A1 bar B1 plus A3 exclusive not B3 into A2 exclusive not B2 into A1 exclusive not B1, A0 bar into B0, where A3 equals to B3. In that place we have to replace with A3 exclusive not B3. Exclusive NOR gate is the formula is AB plus A bar B. And this is A less than B logical diagram. When A3 bar there has a invent that 0 1 truth table for 4-bit comparator. This is a truth table for 4-bit comparator. A3 is greater than B. A3 is greater than B. Then here is A3, B3, A2, B2, A1, B1, A0, B0 are the inputs, comparing inputs. Whereas A greater than B, A less than B, A equals to B are the outputs. When A3 is greater than B, we don't want to compare A2, B2, A1, B1, A0, B1. Whereas output is 1, A greater than B is 1. And A less than B, A equals to B is 0, 0. Here 1 represented with H that indicates high voltage level, and L indicates 0, low voltage level. Here X indicates don't care. A3 is less than B3 is A to B2 as don't care, and remaining all terms are don't cares. Then A3 less than B3 is high. That means A3 less than B. Output is A less than B, that enables 1. And enough outputs are 0, 0. A3 equals to B3, A2 greater than B2. Then A1, B1, A0, B0 we don't compare because of we obtain output as A greater than B. When A3 equals to B3, A2 less than B2. Then we are already obtained here only when A2 less than B2. Obviously A less than B. There is 1. And rest of all don't cares and outputs A less than B. Or rest of all zeros. Same as same. Same all terms we realize like that. A3 equals to B3, A2 equals to B2, A1 greater than B1. When a1 greater than b1, it obviously a greater than b, so output is a greater than b. We don't compare a naught b naught. Is a greater than b is 1. High level voltage, a3 equals to b3, a2 equals to b2, a1 less than b1. Then a less than b is output, is rest of all are don't gets and 0 0 outputs. A3 equals to b3, a2 equals to b2, a1 equals to b1. A naught is greater than b naught, then a greater than b is output, rest of all are zeros. A3 equals to b3, a2 equals to b2, a1 equals to b1. A naught less than B naught, then A less than B is output, rest of all zeros. A3 equals to B3, A2 equals to B2, A1 equals to B1, A naught equals to B naught. When all equals to A equals to B is the output. A3 equals to B3, A2 equals to B2, A1 equals to B1, A naught B equals to B naught. Then A equals to B is the output. High voltage level, low voltage level, external gate. This is a 8-bit comparator using 4-bit comparator. We also design 8-bit comparator using 4-bit comparators, and this is a block diagram of 8-bit comparator using 4-bit comparator. In 4-bit comparator, the A input has 4 bits, A3, A2, A1, A0. Here, and B input has 4 bits, B3, B2, B1, B0, where A3 and B3 are most significant bits, same as A0, B0 as least significant bits. A comparator compares the relation of inputs, relation between the inputs if they are greater than, less than, or equals to. Using 4-bit comparator, we also design 8-bit comparator. This is a block diagram of 8-bit comparator. Conclusion: the design of 4-bit comparators using conditional statements provides a clear and efficient approach to digital comparison logic. Leveraging conditional constructs in HDL supports precise functionality, ease of implementation, and thorough verification. This methodology is integral to creating reliable, scalable digital systems in modern electronics and computing. With the help of this truth table, we can design the logical expressions. These are the logical expression we can design from that truth table. Here is the A equals to B logical expression. It is derived from this truth table. A greater than B. A greater than B. Here is A greater than B is 1. All A greater than B's are 1. So it derives like that. This is the logic diagram of 4-bit magnitude comparator. It draws from logical expression. We take A3, B3, A2, B2, A1, B1, A0, B0. For A3 has 2 lines. One A3, A3 bar, B3, B3 bar, A2, A2 bar, B2, B2 bar, A1, A1 bar, B1 B1 bar, A0 bar, B0 bar. There we perform all and operations, and that goes to OR operation, exclusive NOR operation, and operation. And for A is less than B, it is a OR operation. It is OR operation. A greater than B, it is also OR operation. And operation A equals to B. There is exclusive NOR outputs when A3 B3 bar and A3 bar B3 are the inputs, output is X3. When A2 bar and B2 as in B2 and B2 bar A2 as inputs, the output is X2. When A1 bar B1 and B and A1 into B1 bar as inputs, the output is X1. When A0 bar B0, B0 bar A0 as inputs, the output is X0. And X3 is perform an operation. X3 performs an operation and output gives to the OR A. The SOR performs an operation. This comparator logical diagram drawn from the logical expression A is greater than B, A equals to B. And when A is less than B, the X3, X2 are also included in this, so we have to take in from that only. This is the magnitude comparator, 4-bit magnitude comparator. This is the conclusion of the 4-bit magnitude comparator. In briefly, we discussed the main parts. Mainly, comparator means